Here we are going to analyze the forward bias characteristics of the Zener diode. Look at the circuit diagram in which the Zener diode is connected. The P end of the Zener diode is connected with positive terminal of the power supply, and N end of the Zener diode is connected with negative end of the power supply. And this is the variable one. We are able to vary the voltage from 0 to 12 volt. You can increase the voltage right from 0 to 12 volt. That's why the arrowhead is given here. One resistance is given. The name of the resistance is called current limiting resistor. That one will prevent the flow of high amount of current through the Zener diode. Sometime if high amount of current passes through the Zener diode may get damaged. For that purpose, here that current limiting resistance is given. Here what we are going to do? We are going to analyze the forward bias characteristics of the Zener diode. Here the voltage across the Zener diode that can be measured with the help of the voltmeter. The current passing through the Zener diode can be measured by milliammeter. Are you clear? If you vary the voltage here in the source supply, and the corresponding variation can be observed in the voltmeter. The corresponding variation can be observed in the voltmeter. So the voltage which is given across the Zener diode is called forward voltage. Correspondingly, there will be a variation in the current which is passing through the Zener diode. So the current passing through the Zener diode is called forward current. Since the voltage is measured in the forward bias condition, that's why this voltage is given is called as forward voltage. And the current is measured in the forward bias connection. The current which is passing through the diode is measured in the forward bias connection. That's why the current which is passing through the diode as well as through the milliammeter is called forward current. And it should be measured in milliammeter. It is very small amount of current. Are you clear? So how to start with? Look at already the reading is taken, already the tabular column is filled up. So here the voltage is varied from 0.1, 0.2, 0.3, 0.4. Slowly the voltage is varied. When the voltage is varied with the help of the power supply, the corresponding reading is shown here. For 0.1 there is no current, that's why 0 is entered. The 0 is marking is shown here, the 0th reading is shown in the milliammeter. The voltage is further increased to 0.2, then also milliammeter shows 0. It shows that no current is flowing through the Zener diode. The same thing happens till 0.6. It shows that the diode is not conducting till 0.6. As soon as it reaches 0.7, if the potential difference, here the voltage is varied, is it clear? For 0.7, that voltmeter will show the 0.7 volt and some reading appears, little amount of deflection is shown in the milliammeter. It shows 2 milliampere. For 0.7 volt, the reading shown in the milliammeter is 2 milliampere. Very small tiny current, it starts flowing through the Zener diode. When it is further increased to 0.8, the current is start increasing and it reaches 12 milliampere. When it is further increased from 0.8 to 0.9 volt, the current is further increased to 25 milliampere. Now all the values are tabulated and we have to take a graph sheet. With the help of graph sheet, we are going to draw the forward bias characteristics of the Zener diode. Already the values are plotted. Just to save the time, all the values are plotted. I am going to connect the points which are already plotted. Look at here. Now at 0.7, the current starts increasing, current starts flowing. Now if all the points are connected, you will get the graph like this. The graph what is obtained in Zener diode, that is looking similar to the forward bias characteristics which one was observed in the case of junction diode. Are you clear? There also, in the case of junction diode, current that starts increasing, current starts flowing at 0.7 volt. Here also in the case of Zener diode also, since it is silicon, the current starts flowing from 0.7 volt. So the graph which is drawn, the forward bias characteristics graph which was drawn already in junction diode, and the forward bias characteristics curve which is drawn in the case of Zener diode, both are looking similar. Are you clear? So it is not, this graph is not much significant. Are you clear? The more preference and significance is given for reverse bias characteristics in the case of Zener diode. So this is less significant graph. Are you clear? But you have to know what is happening when the Zener diode is connected in the forward bias. The graph is drawn in the first quadrant. The graph is drawn in the first quadrant. The voltage, forward voltage is taken along x-axis. The forward current is taken along y-axis. Later the graph is drawn here. The current, it starts increasing at 0.7 volt now. Such 0.7 volt can be called as knee voltage. It can be called as, what is this? Knee voltage. Are you clear? So at knee voltage the current starts increasing. So the knee voltage of the Zener diode is how much? 0.7 volt. Very simple one, but you should know. Okay. Here the graph which is drawn with the help of Excel sheet is shown here. Nearby the corresponding readings are tabulated in the tabular column.